Okay, now let me take a look at questions 9 through 12. This is what we call Pythagorean theorem. A Pythagorean theorem is very, very important. Very, very important. People in construction know this one pretty good. They know it as tricks. There's a trick that if you guys go, they know it as the 3-4-5 trick. You can ask anybody in construction, someone that has been doing construction for a long time. They call it 3-4-5. That's how they check if a corner. They call it a perfect corner. Basically, if there's a corner that has a 90 degrees. Now, this is what we're going to be doing. Pythagorean theorem. Let me zoom in. So this is what we're going to be doing. I'm going to look at a right triangle. So when a right triangle, I mean there's a corner that has a 90-degree corner. So that's what we call a right triangle. Let me call my sides A, B, and C, right? There's three sides, A, B, and C. Now, look for the biggest side. That's the side that is diagonal. Let me call this C. That side has a name. It's called the hypotenuse. But for right now, let me just call it C. Remember how I said I was going to call it A, B, and C? So I'm going to call my biggest side C. The other two sides, I'm going to call one of them A, the other one B. It does not matter which one is which. So I'm going to choose this to be A and this to be B. Again, which one is A, which one is B, it does not matter. Now, what we're going to be doing, Pythagorean theorem, in order for me to know the angle, the corner is 90 degrees, we have a rule that we call A squared plus B squared is equal to C squared. Like I said, if you guys go to construction people and they call it the 3-4-5 rule, so the biggest side is 5. If you think about it, 3 squared plus 4 squared, it is equal to 5 squared. That's why they call it the 3-4-5 rule. Okay, now let's take a look at question number 9 here. Find the missing side of each triangle. Leave your answer in simplest radical form. Okay, yesterday we talked about how to simplify a radical. So that means I might have to simplify some radicals. Let me label my sides A, B, and C. C is the longest side, is the diagonal side. So I'm going to call this C, this one A, and this one B. I know I have to deal with everything squared. So x squared is just x times x, it's x squared. Let me take a look at 15. Right, 15 squared, basically 15 times 15 is 225. I'm dealing with everything squared. Now, how about b squared? How much is 5 radical 2 times 5 radical 2? Let me do that here at the side. 5 radical 2 times 5 radical 2. If I multiply the whole numbers, that's 25. If I multiply my radicals, that is 4. Square root of 4 becomes a whole number, and 25 times 2 is 50. So this measurement is 50. Notice how I squared each of my measurements. I did a squared, b squared, and c squared. And I remember my formula. I see it there on my screen. A squared plus b squared is equal to c squared. So let me write this as x squared plus 50 is equal to 225. Let me separate my sides through the equal sign. Now I want the x squared by itself. So the plus 50, this plus 50, let me move it to the other side as a minus 50. Don't forget to switch the sign. So that gives me that x squared is equal to 175. Right? 225 minus 50 is 175. I ask you to solve for x, not x squared. Okay, so how am I going to do the square? Well, with the square root, I'm going to say x is the square root of 175. and then simplify if possible. Nice, I know how to do this. 175, let me break this into two radicals. So I'm thinking two numbers that multiplied equals 175, one of them being a perfect square. So I'm gonna go 25 times 7, right? We talked about how to simplify yesterday. The square root of 25 becomes 5. So my answer is 5 radical 7. Easy. How we're gonna type this? 5 RAD for radical, and then a 7 inside parentheses. No spaces anywhere. All together. Okay, let's take a look at this work again. So let me look at question number 10. Let me label my biggest side, the one side that is diagonal, let me label it C. And the other sides, I'm gonna call them A and B. And I'm gonna square everything. Let me start with this side, x squared. Now 2 radical 2 all squared. So I'm thinking 2 radical 2 times 2 radical 2. That gives me 4. If I multiply the whole numbers, 4 radical 4. But radical 4 is a whole numbered, so that gives me 8. Okay, I had to square one of the sides, right? 8. How about the other side? I'm gonna go radical 13 times radical 13. That gives me radical 169. Oh, that's a perfect square. Isn't the square root of 169 13? Isn't that how we got to it? 13 times 13. Okay. Let me highlight a couple things. Here you see your C squared. Here you see your A squared. And here we see our B squared. So that means when I write this, I'm gonna write 8 plus 13 is equal to x squared. Because remember, I have to write A squared plus B squared is equal to C squared. But then 8 plus 13, we know what that is. That's pretty simple. 8 plus 13 is 21. So 21 is equal to x squared. That means that x must be the square root of 21. Now, can we simplify that? 21, I think of this as 7 times 3. But the 7 is not a perfect square. The 3 is not. No, that's as simple as we can go, right? Okay, so my answer is square root of 21. How am I going to type this? Rad 21, radical 21. Not bad. Let's take a look at question number 11. The biggest side, the side that is diagonal, that's my C. The other side, one of them is called A, the other one's called B. Let me square all my sides. So looking at A, x times x, it's gonna give me x squared. Looking at B, 11 times 11, that's gonna give me 121. Looking at C, 16 times 16, that's gonna give me 256. And remember, I have to write A squared plus B squared is equal to C squared. So let me write this as x squared plus 121 is equal to 256. Good. Let me break my sides to the equal sign. I want the x squared by itself. So this plus 121. Let me move it over as a minus 121. So that gives me that x squared is equal to 256 minus 121 is 135. So that means that x is equal to the square root of 135. Well, simplify that if possible. I'm thinking 135. I'm thinking I can simplify this. I'm going to write this as two radicals. Remember, one of them has to be a perfect square. And then I'm thinking, can I use 4? Can I write a 4? I see my calculator. I go 135 divided by 4. No, it gives me a decimal. Okay, so I cannot do that. Can I use 9? 135 divided by 9 gives me 15. Okay, not a decimal. So I know that 9 times 15 is 135. I know the square root of 9 is a perfect square. Simplifies to 3. So my answer is 3 radical 15. Let me box that. If I had this on a piece of paper, easy to write. Now, how am I going to type this? 3 rad 15. 3 radical 15. Not bad, Mr. Leonzo. How about number 12? Remember, first I'm going to label my sides A, B, C. The one side that is diagonal, which is the biggest side, that is the C. So I'm going to call this side C. So I'm going to call this side A, and this one's B. Again, which one is A, which one's B? It doesn't matter, as long as C is the longest one. But I have to square each of them, right? So let me multiply each by itself. X times x gives me x squared. 8 times 8, that gives me 64. 14 times 14, that gives me 196. So I figure what was a squared, b squared, and c squared. Because I remember Pythagorean theorem says a squared plus b squared is equal to c squared. So I have that x squared plus 64 is equal to 196. Okay, let me separate my sides to the equal sign. My plus 64, let me move it to the other side as a minus 64. So that gives me that x squared is equal to 132. That means that x is the square root of 132. Can I simplify this? Can I simplify this? Can you think of two radicals? Right, so can you think of two numbers that multiplied equals 132? Well, let's see. I know the smallest is 4, so let me see. Can I use the 4? The smallest perfect square that I can use is 4. 132, right? Use a calculator if you need to. 132 divided by 4 gives me 33. Okay, not a decimal, so that's good. So that basically tells me that 4 times 33 is 132. The square root of 4, it's a whole number, right? Square root of 4 is 2. So my answer here will be 2 radical 33. Now radical 33 I cannot simplify anymore. So I'm gonna write this as 2 RAD for radical 33. Let me write my A better. 2 radical 33. Now radical 33, I know we can break that as 3 times 11. But 3 is not a perfect square, and 11 is not a perfect square. 2 radical 33.